In mathematics, we study relationships between quantities that vary. Many of these relationships can be modeled using functions. In this video, we'll define what a function is, explore f of x notation, understand how functions behave, and look at how to represent them through equations, graphs, and tables. So let's get into it. A function describes how one quantity depends on another. For example, if a tree grows over time, we could model its height as a function of time. So we could have the function h of t equal the height of the tree at time t. For each value of t, we get exactly one h of t. That is, we get one input and one output. So our input will be t, the time, and our output will be h of t, which is the height. You can think of a function as a machine. So let's draw one real quick. So this is our function. And our function takes an input, which we'll say is x, and it produces an output, which is f of x. You give it any input, which in our case is x, the machine applies a rule, and out comes the output f of x. So let's put a rule in here, for example. So let's put a rule in here as an example. So we'll have f of x equals 2x plus 3. Now let's say our input is 2. So we're going to put 2 into the input, and then we're going to apply this rule. So 2 times 2 plus 3, which will be 7. So it'll output 7. Now let's do another input. Let's say our input is -1. That goes in, we apply our rule, and the output will be 1. 2 times -1 plus 3. So that is a simple way to think of a function. Now let's define a function more formally. A function f from set A to set B is a rule that assigns each element of A to exactly one element of B. We write this using function notation as A goes to B. Set A is called the domain. And in this set is all valid inputs. Set B is our codomain. A set that contains all possible outputs. So let's give our sets some values. So let's add 1, then 2, 3, and 4. And then for our outputs, we can say A, B, C, and D. For every input x in the domain, that is for every x that is an element of A, there exists one and only one output f of x in B. If any input had two different outputs, it would no longer be a function. So for our example, 1 can go to A, 2 can go to B, 3 can go to C, and 4 can go to D. This would be a valid function. Now let's say 4 went to D, but it also went to C. This would no longer be a function, as 4 goes to both C and D. Now let's cover function notation. F of x, written as such, is the standard notation we use to describe functions. The f is the name of the function. The x is the input variable. And f of x, when you bring them together, is the output. The result you get when you apply the function to x. This notation helps us communicate precisely not just the output, but how the output depends on the input. You'll use f of x notation constantly throughout precalculus, calculus, and beyond, so it's important to understand both how it's written and what it represents. Not all relations are functions. Let's look at the equation for a circle. X squared plus y squared equals 1. Now if we draw this on a graph, it would look something like this. That is not the best circle. But in our equation, if x equals 0, then both y equals 1 and y equals -1 satisfies the equation. So both 1 and -1 are valid outputs. That means our one input of 0 gives us 2 outputs, which violates the definition of a function. We can test this using the vertical line test, where we draw a vertical line, and if a vertical line intersects the graph more than once, it is not a function. So in our case, we are intersecting right here and right here. So this is not a function by the vertical line test. Functions can be represented in multiple ways. For example, we can use equations such as f of x equals x squared, or we can use graphs, which can show us the increasing, decreasing, and turning points. We can use tables, which show specific x and f of x pairs. So we can have our input x and our output f of x. Or we can use mappings, as seen earlier in the video, where we show inputs paired with outputs in a small finite case. Like this. Regardless of the format, the rule remains the same. Every input maps to one output. So let's look at an equation example. Let's take the function f of x equals 2x plus 1. This is a linear function. It doubles the input and then adds 1. So let's say we have the input -1. We'll plug -1 into our equation. So we'll get 2 times -1 plus 1. This equals -1. Now let's say our input was 0. We would plug in 0 equals 2 times 0 plus 1, which we'll get 1. Now let's say our input was 2. We will plug in 2. So it'd be 2 times 2 plus 1, which equals 5. Every value of x gives us a unique value of f of x. So now let's do a table example with the same function. So we'll have our table with our input x and our output f of x. So let's say we plug in the values -3, -2, -1, 0, 1, 2, and 3. Now if you remember, our function is 2x plus 1. So let's begin plugging in. So for our first input value of -3, we'll get 2 times -3, which is -6, plus 1 equals -5. Let's do -2 now. 2 times -2 is -4, plus 1 is -3. Then for -1, 2 times -1 is -2, plus 1 equals -1. Now when we plug in 0, we'll get 2 times 0 plus 1 equals 1. Then if we plug in +1, we'll get 2 times 1 plus 1 equals 3. Then if we plug in 2, we'll get 2 times 2 plus 1 equals 5. And then finally, if our input is 3, we'll get 2 times 3 plus 1 equals 7. Now let's do a graphing example. Graphing f of x equals 2x plus 1 will give us a straight line with a slope 2 and y-intercept 1. So let's graph it. So our first input is -3, and we're going to get -5 as an output. So it'll be right here. Our next input is -2, and that gives us -3. So it'll be right here. Our next input was -1, which gave us -1 as an output. So that's right here. Then our next input was 0, which gave us 1 as an output, which is right here. Then we had 1, which gave us 3, so right here. Then 2, which gave us 5. Then 3, which gave us 7. Each x on the x-axis corresponds to exactly 1 point on the graph. When we connect the dots, this will give us a straight line. This visual confirms that f of x is a function, and the graph passes the vertical line test. Now that you understand what a function is, you are ready for the next topic, domain and range, how to determine valid inputs and possible outputs. Check out the next video in the Precalculus playlist Like and subscribe if this helped, and feel free to ask questions in the comments. Thank you for watching.